Hello everyone. Welcome to the solution of next assignment on network analysis. In this problem, a capacitor in the circuit is given of 4 microfarad which initially charged capacitor is given with the charge of Q0 at Q0 is 800 microcoulomb. So the charge on this capacitor is 800 microcoulomb with the polarity indicated with this polarity as a positive and with this polarity as a negative. If the switch is closed at time t is equal to 0, obtain the current and charge for t is greater than 0. So we have to write down the equation for current and charge. Though it is written for current and charge, we will also write down for the voltage across capacitor equation. So how to solve this problem? So I will tell you the simplest formula for any RL and RC circuit when it is connected to DC supply. Any voltage, current, charge is to be calculated, use this formula. What is this formula? X, when x at the time t is to be determined, when x is the function of t, what is the value of x at 0 plus just after the switching, that is initial condition, what is the value will be when time t is equal to infinity into e raised to minus t by tau x plus x at the infinity. So x at 0 plus minus x at infinity e raised to minus t by tau. Tau is the time constant plus x into infinity. So first we will determine the tau for this circuit. The tau is calculated in RC circuit. The tau is calculated as R into C. So R is 10 ohm. C is 4 microfarad. So 4 into 10 raised to minus 6. So it will give you 4 into 10 raised to minus 5 second. But here it is 1 by tau is required. So 1 upon tau t by tau. So that is 1 upon tau is required. So I will calculate 1 by tau. So 1 by tau, 1 divided by 4 at 4 into 10 raised to minus 5 second will give you 25,000 seconds inverse. So now we'll write down the voltage equation. So what is required in this equation? X0 plus. So voltage across capacitor is given as VC. So VC 0 plus is equal to charge upon capacitance. What is the initial charge divided by the capacitance? The initial charge in the problem is given as 800 micro. So 800 micro divided by 4 micro. Capacitance is of 4 micro. Hence it gives you micro will be get cancelled. So initial voltage on the capacitor is 200 volt with this polarity as a plus and this polarity as the minus. Suppose this polarity is opposite than the direction of the current, then we have to take it as a minus 200. But 0, when this switch was to be closed, when the switch is closed, at that instant voltage across the capacitor is 200 volt. But when time reaches to the infinity, voltage across capacitor will be equal to the source voltage. So what is the source voltage? Source voltage is 100 volt. So voltage across capacitor will be 100 volt at the time. So in this formula, X is replaced by Vc. So Vc is equal to Vc at 0 plus minus Vc at infinity e raised to minus t by tau. Vc, X is replaced by Vc at infinity. So I will substitute the value of Vc 0 plus. Vc 0 plus is 200. Vc infinity is 100. So 200 minus 100, this will calculate it as 100 minus 25,000 t plus Vc infinity is 100. So this equation will comes as 100 plus 100 into e raised to minus 25,000 t. If we take 100 as a common, voltage across capacitor is 100, 1 plus e raised to minus 25,000 t. So this is for the voltage, though it is not asked in the problem, just for a simplicity, just for making the problem more interactive, I am giving the voltage across capacitor equation. Now what is the voltage equation for the charging current? Now I want to calculate the charging current. Similarly, we will calculate the charging current. Now this is also voltage source, and at T0 plus, this is acting like a voltage source. So 100 volt and 200 volt across this, they are both are the voltage source. So what is the net current which is flowing? V voltage, that is applied voltage, minus, because this is a plus polarity, so it is a minus Vc 0 plus, that is voltage across capacitor at a 0 plus, divided by resistance. So it comes to 100 minus 200 upon 10, it comes to minus 10 ampere. It indicates that though the direction is given like this, the current is flowing in opposite direction because it comes to minus 10 ampere. And what is I infinity? At the time when time t is to infinity, when capacitor is fully charged with the 100 volt, no current will flow through this, so I infinity is equal to 0 ampere. Again, in this equation, x is replaced by I I0 plus minus I infinity e raised to minus t by tau plus I infinity. So I0 plus I0 plus is minus 10 minus 0 because I infinity is 0 e raised to minus 25,000 t plus I infinity is 0. So this comes to minus 10 e raised to minus 25,000 t. Now similarly we will do for a charge. What is the initial charge on the capacitor? It is 800 microcoulomb. It is given in the problem. Initial charge is 800 microcoulomb. When it is reaches to the infinity, what is voltage across capacitor? When it is reaches to the infinity, voltage across capacitor is equal to 100 volt. So Q is equal to CV. So C into voltage across capacitor. Q infinity equal to VC at the infinity into C. So what is the VC at infinity? VC at infinity is equal to 100 and the charge is 4 micro. So 100 into 4 micro, it comes to 400 microcoulomb. I'm keeping micro as it is, so it gives you 400 microcoulomb. So again, in this equation I will replace x by q. So x is replaced by q, x is replaced by q, x is replaced by q. So q plus minus q infinity e raised to minus t by tau plus q infinity. So substituting the value of q plus 800 minus 400, 800 minus 400 e raised to minus 25,000 plus 400. So this will give you 400. So 400 is taken as a common. So 400 1 plus e raised to minus 25,000 t, that will be the charge across capacitor at any instant. Let us solve the next problem. So is it simple? When you remember a simple one equation only, you can write down for any. Only you should be able to calculate what is the value of x0 plus and what is the value of x infinity. Only that two things are required. Next, 2 microfarad capacitor with initial charge of Q0 is equal to 100 microcoulomb is connected across a 100 ohm resistance at time t is equal to 0. Calculate the time in which the transient voltage across the resistance drop from 40 volt to 10 volt. So voltage across resistor, it is asked in this problem. Sorry, but I have solved for the voltage across capacitor. uh, Voltage across capacitor drops from 40 volt to 10 volt. So for let us consider that this is resistor is not there, it is a capacitor. Same you can do for the resistor also. So we will write down the equation for resistance and you can do also. So x is equal to x 0 plus x infinity. That formula remains same. First I will calculate tau. Tau is equal to RC. R is 100 ohm and C is 2 microfarad. So 2 into 10 raised to minus microfarad, it comes to 200 into 10 raised to minus 6 second. If I take 1 by it will give you 5000 second inverse. So equation of cross voltage across capacitor, equation of voltage across capacitor is equal to 0 plus q by c. So q is 100 microcoulomb initial charge divided by capacitance is 2 micro. So voltage across capacitor is equal to 50 volt. When this capacitor is fully discharged, obviously voltage across capacitor will be equal to 0 at the infinity. So substituting this value in this equation, so Vc 0 plus is 50, Vc infinity is 0 and Vc infinity is 0. So this equation is 50 e raised to minus 5000 t because 1 upon t is 5000 t. So 50 e raised to minus t, this is the equation for Vc. So what is the value of Vc at 40 volt? What is the value of Vc at 40 volt? That is at what time Vc will attend the 40 volt. So I will substitute Vc is equal to 40, then I calculate the time t1. So taking the 50 transfer on this side, so 40 divided by 50, taking the natural log of 40 by 50 divided by this minus 5000 will give me this time. Time is equal to 0.045 millisecond. When this when this voltage is dropped to 10 volt, when this voltage is dropped to 10 volt, see that voltage is dropped to 10 volt, this nothing but a 10 volt. So 10 into 50, in this equation Vc is substituted as a 10, then I will calculate the T2. Sorry, this is not a T1, this is a T2. So what is the value of T2? T2 is calculated as ln divided by 10 divided by 50 divided by 5000. So it will give you 0.227 millisecond, 0.227 millisecond. Hence what is the time required to drop the voltage from 40 volt to 10 volt? That is nothing but the voltage across resistance, because it's a discharging problem. So 0.0227 minus, that is this time minus this time, that is 0.227 minus 0.045, that it comes to 0.232 millisecond. So that is the voltage across capacitor or voltage across resistance when it falls from 40 volt to 10 volt. This much timing is required, 0.232 millisecond. Let us solve the next problem for inductor. In series RL circuit, R is given as 10 ohm and L is given as 1 Henry. Has a 100 volt supply at T is equal to 0. Find the current when T is greater than 0. Again, same equation, X is equal to X 0 plus minus X infinity e raised to minus T by tau plus X infinity. So how will calculate tau? Tau in case of RL circuit is R by L, that is 10 by 1, it is 10 second, but 1 upon tau is equal to 0.1 second inverse. So I have calculated 1 upon T time. What is the voltage across inductor initially? Initially the inductor act like open circuited, means total applied voltage will come across the inductor since 100 volt. When at time t tends to infinity, voltage across inductor will become 0. So when the voltage across inductor will become 0, so I will substitute X as a VL 0 plus VL infinity. Substituting the value of VL 0 plus and VL infinity in this equation, and 1 upon tau is equal to 0.1 second, I got the equation 100 e raised to minus zero point 0.1 t. Similarly, this can be calculated for current. Initially current, inductor acting like open circuited, hence the initially current is equal to 0 volt, and at infinity only resistance will be in opposition because inductor will behave like a short circuit. So 100 divided by 10, that is 100 volt divided by 10 ohm resistance, and it is 10 ampere. So again in this equation X is replaced by IL. So if it is replaced by IL 0 plus minus IL infinity e raised to minus T by T plus IL infinity. Substituting the value of IL at 0 plus and infinity, 0 minus 10 e raised to minus 0.1 T plus 10, that is equal to 10, 1 minus e raised to minus 0.1 T ampere. So this is the value of the current when series RL circuit is connected across the DC supply. Thank you.